Hello there and welcome to a brand new lesson. This is Have Your Numbers where we learn maths the easy way. In this lesson, we are looking at partial fractions. We are on case 3, that is irreducible quadratic functions. By the end of this lesson, you should be able to identify irreducible quadratic factors in a denominator. You should be able to understand why quadratic factors need a linear numerator. You should be able to decompose proper fractions with irreducible quadratic factors. And finally, you should be able to handle improper fractions by performing long divisions first. On our left hand side, we have answers to the trial questions of our previous lesson, that is the lesson on case 2. Also on our right hand side, we have some vocabularies you hear me use as the lesson proceeds. You can pause and quickly take a glance before we begin the lesson. To begin, one might ask, if we have case 1 and case 2, why do we need case 3? You realize that there are some quadratic functions that cannot be factorized with real numbers. You see, the reason being that they are discriminant. The discriminant, which is b squared minus 4ac, is less than 0. For this reason, we can't factorize them over the set of real numbers. So for such quadratic functions, an x squared plus bx plus c, anytime you are evaluating and you have a denominator of this form, then the term that takes that denominator would also take a numerator of bx plus c or ax plus c, whatever the case may be. The most important thing is you have a linear function, that is a constant times x, then plus a constant on its own. What this means is, if we are to evaluate a function, let's say p of x, which is all over x minus a, and then x squared plus bx plus c, then we would have a constant that will take this first one. You see, this is a linear factor. So we have a over x minus a, but then that numerator that would work with this denominator is supposed to be a bx plus c, that is a linear factor. Then you put down your quadratic. If you're able to get this decomposition formula, the rest is up to you to solve by taking your time and then applying the basic rules we have already discussed. Hence, in order to be able to solve this type, that is case 3, the first thing you need to do is to check if the fraction is a proper fraction. When it comes to polynomial or rational functions, we say a fraction is a proper fraction if the degree of the numerator is less than the degree of the denominator. But if that is not the case and the degree of the numerator is equal to or greater than the degree of the denominator, it is an improper fraction. And you'd have to divide to get your quotient before you now focus on the proper fraction. And if you're able to do that, then you now come to step 2, where you use your decomposition to work on the proper fraction. So if there's a linear, then it's going to be an a over the linear, then your linear numerator over your quadratic numerator over your quadratic what? Numerator. The rest is just the same procedure. So it says multiply both sides by the full denominator so that we get only the numerators equating. Then we substitute the root of the linear factor to find a. This is the cover up method or the substitution method, after which you can use your undetermined coefficients to solve for the remaining constants. This will be best understood if we actually pick some questions and then try. So let's solve some questions based on this understanding. So our first question we have here says, we are to decompose 2x squared plus x plus 1 all over x plus 1, then x squared plus 2. Now, we are to check whether or not it is a proper fraction. If we are to expand the denominator, x multiplies x squared to give us x cubed. And hence, for the denominator, its degree, the highest degree is what? 3. But then for the numerator, the highest degree is 2. So that is settled. Hence, we can write our what? Decomposition formula, which becomes a 2x squared plus x plus 1 all over x minus 1 and then x squared plus 2. Now, this is equal to this we have here, which is x squared plus 2 is the quadratic factor we are talking about. Because for x squared plus 2, there is no way we can factorize it. If you want it to look like the standard quadratic, that is x squared plus 0x plus 2. There are no factors of 2 that when you add, you'd get 0. You see, in other words, the discriminant is less than 0. So with that, we say for this linear factor, it is going to take an a over the linear factor, which is x minus 1. Then we have plus. For the quadratic factor, we are going to use a linear numerator, which is bx plus c all over your x squared and then plus 2. At this stage, as we have always done, we would have to multiply each and every term by the LCD. So multiplying this by the LCD, it just cancels out. So that will be left with a 2x squared plus x plus 1, which is equal to, if you multiply this here by the LCD, we have x minus 1 cancelling out x minus 1. And so we'll be left with an a multiplying x squared plus 2. Then this time around, for x squared plus 2, it also cancels itself. And then we'll be left with what? A bx plus c in a bracket. Then in another bracket, you have x minus 1. It is important you put your bx plus c in a bracket. If not, if you are to write bx plus c, then into bracket x minus 1, it will imply it is only the c that is multiplying or that is being distributed over the terms in the bracket. But that isn't the case. Everything that is the b and then the c, they are both multiplying the x minus 1. In that case, we can quickly use our cover-up method over here. We took our time to look at the cover-up method in case 1. If this is actually the first lesson you are watching, then you can refer to that to enhance your understanding on the cover-up method. So our a is simply a 2x squared plus x plus 1 over this denominator, but then excluding that which is under a. So that is what? X squared plus 2. But then we'll be evaluating it at the value of x, which makes the denominator of a to be 0. That is to say, if x minus 1 is equal to 0, then our x will be equal to 1. So we'll evaluate this at x equals 1. So with that, we then have our a, which is equal to, substituting 1, we have 1 squared, which gives us a 1, times 2 gives us a 2, then plus a 1 plus 1, all over. We have 1 squared and then plus 2. Simplifying, we have 2 plus 1 plus 1, which gives us a 4. So 4 over 3. That becomes the value of what? A. So a is 4 over 3. Now, there is no way we can use the cover-up method to get the subsequent constants. You see, hence, we'll need to expand. You could have as well used the substitution. So expanding from this particular line, we have 2x squared plus x plus 1, which would then give us, multiplying a by x squared gives us an ax squared Then a times 2 gives us a positive 2a. Then we now come to bx times x. That gives us a bx squared. And then bx times negative 1 gives us a negative bx. C times x gives us cx. And then c times negative 1 gives us a negative c. So with this, you can now group terms with respect to their variables. So we have 2x squared plus x plus 1. Let's group all those with x squared. So with that, we have ax squared and then bx squared, so that we pick only their coefficients. So we have a plus bx squared. Then those with just x, we have negative b and then plus c. So we have negative b and then plus c with our x. And then when we come to the constants, what do we have? We have a 2a, and then b has no constants, and then minus c. So 2a minus c. So based on this, we now equate the coefficient of like variables. So for those of x squared, we have, there is a 2 here, so 2 is equal to, this is for the x squared on our right hand side, so 2 is equal to a plus b. This becomes our equation 1. Then for that of x, we have 1 is equal to, the coefficient of x over here is a negative b plus c, and that becomes our equation 2. Then that of c, we have just 1, that is the constants. So we have 1 is equal to the constant we have over here, which is negative, which is 2a minus c. This becomes our equation 3. Now, if you are having the Casio calculator, you can always just punch this out to get all your values. But since we have our a to be 4 over 3, then we can say from equation 1, which we know 2 is equal to what? A plus b. Let's substitute our a, which would then imply that 2 is equal to the a, which is 4 over 3 plus b. So making b the subject, we have 2 minus 4 over 3, which should be equal to our b. Hence, our b is equal to a 2 over 3. That is evaluating 2 minus 4 over 3. 2 minus 4 over 3, 2 can be written as 6 over 3. You see? So 6 over 3 minus 4 over 3, we have our 3. Then 6 minus 4, giving us what? A 2. So 2 over 3. Now we come to, we have our a, we also have our b. Hence, we need our c. The easiest way to get our c is by using equation 2. So from equation 2, and we know equation 2 was 1 is equal to negative b plus c. So making our c the subject, we have our c, which is equal to 1 plus b. So our c is equal to 1 plus the b was 2 over 3. 1 plus 2 over 3 then gives us a 5 over 3. So we have our a, we have our b, and we also have our c. Now let's go to our final result. So this implies that since we have now gotten all the factors, all the values of the constants, we can now do our substitution. So it simply implies we have a. Our a was 4 over 3. So 4 over 3 over x minus 1. Then plus b was 2 over 3. So 2 over 3 x. Not forgetting this x over here. So 2 over 3x. Then plus the c, which was 5 over 3. All over the x squared plus 2. Now, we would have to look for a better way to write this. So remember, if you have 2 over 3x, that is, if we want to add the numerator, so 2 over 3x plus 5 over 3. Since the denominators are the same, we can say we write at 3, that is, they are like terms. So 2x plus 5. This is what we are going to get. Okay, so let's keep that somewhere. We can come all the way here and say we have 4 over 3 all over x minus 1, then plus 2x plus 5 over 3 all over the x squared plus 1. So if you remember all that we've done so far under partial fractions, when there's a denominator, we use the denominator as a coefficient of this main denominator of the fraction. So what I mean is, if you want to rewrite this, it's going to be a 4 over, and this denominator comes down, so that it becomes a 3 into bracket x minus 1, then plus, this also has a denominator of 3. So 2x plus 5 all over 3 into bracket x squared plus 1. As simple as that. And that is going to be the partial fraction of what we have here, which is 2x squared plus x plus 1 all over x minus 1, then x squared plus 2. We have done nothing different here. You see, the only thing new is we getting to understand that if there's a quadratic factor, that is irreducible quadratic factor, what we need to do is to also represent that with a linear numerator. You see, then after which the rest of the processes follow accordingly. So with that, let's continue with another question so that we enhance our understanding. So our second question we have here says we have to decompose x cubed plus x squared all over x squared minus 1. Now, if you look at it carefully, the numerator we have here, or let me say the whole fraction, is actually an improper fraction. The reason being that the degree of the numerator, which is 3, is greater than the degree of the denominator, which is 2. You see, so anytime it is equal to or greater than that of the denominator, you say it's an improper fraction. So before we can apply partial fraction, we must first of all perform the polynomial division. So for x cubed plus x squared all over x squared minus 1. Now, when it comes to polynomial division, before we do that, we'll have to make sure we have the degrees in descending order. So instead of the x cubed plus x squared, we'll rewrite it as x cubed plus x squared, and then plus the 0x all over. We have x squared plus 0x and then plus or minus 1. So minus the 1. You can choose to add 0 here. That is fine. We do this so that you would have placeholders for all the terms in the general formula. So with this, we can now come and then perform our division. That is x cubed plus x squared plus 0x plus 0. We are dividing it by x squared plus 0x minus 1. And we know we perform the division one after the other. So we start with x cubed. X cubed divided by x squared gives us an x. So x squared times x gives us an x cubed. Then 0x times x That also gives us what? 0x squared. And then we have negative 1 times x. That gives us a negative x. After which we do our subtraction. So a 0x minus x minus x will give us an x. That is a positive x. Then x squared minus 0x, we still maintain our x squared. X cubed minus x cubed goes off. You see? So with that, we are left with what? X squared plus x. You can choose to bring your 0 down. That is fine. Then we start the whole division again. So you have x squared divided by the x squared we have over here. That gives us a 1. You see? So we now do our multiplication. X squared times x squared times 1 gives us our x squared. Then 0x times 1 gives us a 0x. Then negative 1 times 1, that gives us a negative 1. You see, these 0x's and all that, they are just placeholders. You see, they would help you so that you don't get confused. So 0 minus negative 1 gives us a 1. Then x minus 0x would give us what? An x. Then we have x squared minus x squared. They vanish. And this is what we have. Anytime you are doing a long division, you'd always want to ask yourself before each step that, is the degree of what you have here equal to or greater than this? If it is equal to or greater than, you can continue. But if it is less than, there is no need continuing. Hence, after this long division, what we have is what? We have this as our whole. Just as we do our long division, this is our quotient. So it implies we have our quotient, which is x plus 1, then plus the remainder, which is also an x plus 1, all over the divisor, which was x squared minus 1. Looking at what we have here, our focus is now going to be on this one. You see, so the x plus 1 over x squared minus 1. And this can be rewritten as x plus 1 over x minus 1 and then x plus 1. You know, this is difference of two squares, you see. And obviously, the numerator is a factor of the denominator. So what are we going to do? We can do our cancellation. So we can say the x plus 1 cancels out x plus 1. And we have left 1 over x minus 1. And that is all of this we have here. That is all of this. You see what we've been able to obtain from what? This particular fraction. Now, remember, we are still in our partial fraction process, you see. So this whole fraction has been rewritten as this over here. Hence, it simply implies that our x cubed plus x squared all over x squared minus 1 is actually equal to the x plus 1 and then plus, so this is the x plus 1, then plus this one, which we have rewritten it as what we have here. So plus 1 over x minus 1. And that will be all. You see, that is just all. So x plus 1 plus 1 over x minus 1 would then become our partial fraction for this particular compound fraction. Now, the fact that you have an idea about what you want to do doesn't necessarily mean anytime you have a question, you just go straight forward and start answering. You'd have to analyze and then see what you would have to do. You see, because with this one, if you went straight forward to go and then write our decomposition, we would have gotten it wrong. But then the instructions is first of all check whether or not it is a proper fraction. If it is, then you can continue. But if it is not and it's an improper, you'd have to rewrite it. Let's solve our last question for this session. So looking at our last question we have here, it says we are to decompose 2x squared plus 3x plus 5 all over x minus 2, then x squared plus x plus 3. So looking at the question, it says x squared plus 3x, then plus 5 all over x minus 2, and then x squared plus x plus 3. So the first thing to look out for is to check whether or not we can factorize. Now using our discriminant, we know b squared minus 4ac. Substituting, your b is 1. So we have 1 squared minus 4 times a, which is also 1, and then c, which is 3. That gives us a 1 minus 12. And that is far less than what? 0. So we said if our discriminant is less than 0, then it simply means this cannot be factorized over real numbers. Hence, we have confirmed it is a quadratic. Moreover, x times x gives us x cubed. And that also confirms that the degree of the denominator is greater than the degree of the numerator. So our decomposition formula is going to be a over, because this is a linear factor, so a over x minus 2, and then plus, this being a quadratic, we have a linear numerator, which is bx plus c all over x squared plus x plus 3. And as we have worked so many times, we'll have to multiply each and every term by our LCD, which is the x minus 2 into bracket x squared plus x plus 3. Now for the left hand side, if we do that, we would be left with our numerator, which is x squared plus 3x plus 5. Then for our right hand side, we have a. Its denominator will cancel out this when we do the multiplication. So we have a into bracket x squared plus x plus 3. Then plus the bx plus c times the x minus 2, because it will also cancel out the quadratic. Now, I do believe that you understand all that we are doing, but sometimes because of pressure in the exam hall and all that, we make certain petty mistakes. One being what I just mentioned. You'd have to put a bracket. You have to put bx plus c in a bracket so that you would be reminded that everything in here is multiplying this other bracket. If not, you'd be confused and you might think it is only c that is doing the multiplication, but it isn't so. So expanding, we have our x squared plus 3x plus 5 equals, multiplying with our a. Well, we could also use the cover up rule to solve for a. So let's do that quickly and then see what we are going to get. We can use the cover up rule to solve for a, because if we substitute x to be 2, we have this bracket giving us 2, and all of this vanishes, you see. Nevertheless, we'll still come to the step where we would have to expand everything. So the cover up rule is just a convenient way to get one of the variables, so that after your expansion, that is during the method of undetermined coefficient, you wouldn't have to solve all the 3 equations simultaneously, because you already have one of the variable. Hence, solving for a, we know our a is always the numerator we have here, which is x squared plus 3x plus 5 all over this denominator but excluding that of the a, because it is a we are solving for. So we have x squared plus x plus 3. And we are evaluating it at the value at which a's denominator gives us 0. If x minus 2 is equal to 0, then it simply means x is equal to 2. So our x is equal to 2. Substituting to solve for a, we have our a which is equal to 2 squared. 2 squared gives us a 4, then plus 3 times 2. 3 times 2 gives us a 6, and then plus a 5. All over 2 squared as well gives us a 4, then plus a 2 plus a 3, which then gives us a 4 plus 2 is a 10. 10 plus 5, we have a 15. So 15 over 4 plus 2, 6. 6 plus 3 gives us a 9. If you have to simplify further, we have 3 dividing 15 to give us a 5, and then into 9 to give us a 3. So it implies our a is a 5 over 3. Now to what we were running away from. So we'll have to come back here and then expand every bracket, so that for our left hand side, we maintain our x squared plus 3x plus 5. And this is actually the method of undetermined coefficients. So a multiplies all these to give us a times x squared, which is ax squared, then a times x, which is ax, and then a times 3, which is a 3a. And then we have our bx times x. That gives us a bx squared. Then bx times negative 2, that gives us a negative 2bx. And then that of the c. So c times x gives us plus cx. And then c times negative 2, which will give us a negative 2c. So with that, we can group all the like terms, so that we have an x squared plus 3x plus 5, giving us, let's work first of all with the x squareds. So for the x squared, we have just a plus b. That is, we are adding the coefficients, you see. So we have a plus b with our x squared. Then for that of the x's, you see we have a, that is from here, we have minus 2b, and then we have c. So plus into bracket a minus 2b, and then plus c. And then comes the constants, where we have a 3a, b has got no constant, but then c has got a negative 2. So 3a minus 2c. We then equate the coefficients. So for the x squared, the coefficient of x squared here is 1. So it simply means 1 is equal to the coefficient of x squared over here, which is a plus b. This becomes our equation 1. Now for the x's, the coefficient of x is 3. So 3 equals the coefficient of x over here, which we refuse to write. So the coefficient of x over here is going to be a minus 2b, then plus c. That becomes our equation 2. And then for the constant, we have 5. So 5 is equal to what we have over here, which is 3a minus 2c. This is our equation 3. Not forgetting, we have our a already. Hence, we can use any of the equations to solve for any of the remaining variables. From equation 1, we know a plus b is equal to what? 1. So substituting, we have our b, which would be equal to 1 minus a. And we know what our a is. So 1 minus 5 over 3. Our b then is equal to a negative 2 over 3. 1 minus 5 over 3 will give us a negative 2 over 3. So we have our a and we also have our b. Hence, we need to solve for our c. Comparing the two equations where we have c, that is equation 2 and 3, I think it would be best we use 3. So from equation 3, we know 3a minus 2c should give us a 5. Substituting a, we have 3 into bracket 5 over 3 minus 2c equals 5. This gives us a 5. That is, after this 3 cancels out this 3. We have 5 minus 2c is equal to what? 5. Now, making c the subject, we are going to get a negative 2c, which is equal to a 5 minus 5. Easy. And we have a negative 2c, which is equal to a 0. This is only possible if c itself is equal to 0. So we have our a, which is equal to the 5 over 3, and then b, which was also equal to negative 2 over 3, and then c, which was also equal to 0. And substituting into our decomposition formula, we have a, which is 5 over 3, and we know how we can best write it. So we have 5 over 3 into bracket x minus 2, then plus, since c is 0 and it's not going to appear, the b on the other hand is a negative 2 over 3. So that affects this plus to give us a negative. So negative 2 over, not forgetting our x, so 2x over 3 into bracket x squared plus x plus 3. Why? Because the c is what? 0. And there's no need bringing it there. So this becomes the partial fraction of all this we have over here. And I hope you agree with me that it is very, very simple and straightforward. The most important thing is you pay attention to what you are doing. You see, maths is a language. And when you want to speak this language, you just have to pay attention to each and every move you take. You might have the idea and then continue to solve, but then if you are distracted and you are not able to continue where you left off, you change your plus to minus and then a minus to a plus, which would in turn affect the accuracy of your solution. We end here, but as usual, I'll leave it some exercises so you try on your own. So here you have 5 questions to test your understanding of all the cases we have considered so far. They are very simple and straightforward. If there's any issue of concern, you can always let me know at the comment section. When I'm notified, I would address that for you. This Have Beyond Numbers where you learn maths the easy way. If this lesson was of help to you, you can choose to subscribe if you so do, so that anytime I release a video, you'll be notified as well, so we learn together. See you in our next lesson, and bye for now. Do stay safe.